Welcome to the History of Salmon presentation, coming to you live from our SIC virtual tank. You can see behind me here. Right now we have sack fry, so you see the little guys with their yolk sacks still attached, swimming around. But what we're going to do today is learn about the history of salmon in Michigan. So let's get started. I'm Tracy Page. I am the Aquatic Education Coordinator for the Michigan Department of Natural Resources. It's a really long title to say that I help everyone learn about our aquatic resources and fish and our rivers and lakes and Great Lakes, and hopefully instill an appreciation and want to get people out there and using the resource, but also to hopefully be a steward of the resource, to take care of that resource. And I work for the Michigan Department of Natural Resources. What we do is take care of the natural resources of our state for you, right? So we work for you. The people of Michigan are who own the resources. So those state parks and campgrounds and all those different areas that you might use, we take care of them for you because you technically own them. And we get our funding from license dollars and from those little P's on your license plate sticker that let you get into state parks to go camping. And all of those license fees go back to the DNR to be able to take care of those resources for you. So that's what we do. And part of that resource is the Great Lakes and the fish that are in it. So we have stocking programs and we have hatcheries in our state. And all of those things are to support the resource so that people can get out and fish and recreate and have lots of fun. So what we're going to learn about today is the history of salmon in Michigan. So what we want to do is start with the story and understand what you know about salmon. So think about what you know about salmon or what your family members might know about salmon. A lot of times people will say, well, I have eaten salmon, right? So a lot of people have eaten salmon, maybe from the Great Lakes or just store-bought, and you don't really know where it's from. So that's part of it. Another thing is people could sometimes say, well, my dad, my aunt, my grandpa has been fishing for salmon, either from a boat, maybe with a charter company or their own boat, or in a river when those salmon are coming back to spawn. Another one we hear quite often is the bear. Bears eat salmon, right? So as we see in our picture, there's the bear standing in the river looking majestic and eating those salmon as they jump, and he's catching them, and it's very dramatic. But a lot of the time, that's not the case, especially here in Michigan, because we don't have this species of bear. We have black bear in Michigan. Now, unlike the Kodiak bears that live on Kodiak Island in Alaska, and they're going to go out in the rivers and they're going to catch those salmon, our black bears aren't quite that ambitious. If the fish were to be dead and washed on the side of the river, they would totally eat it. But our bears tend to spend most of their time hanging out in the woods, being lazy and eating berries and bugs. So it's a little bit different. So that's kind of a misconception that our bears eat salmon, because ours don't regularly do what this Kodiak bear is doing here in the picture. So there's a lot of things we know about salmon, but one thing is the story of salmon in Michigan doesn't start in Michigan. And it started quite a while ago, right? So we have all of these different things going on in Michigan, and we're keeping track of all these different fish species for years and years and years. But the story of salmon actually doesn't start here. So where does it start? Well, it starts out in the Atlantic Ocean with the seagoing rocksucker, which is not a salmon. So the seagoing rocksucker species is native to the Atlantic Ocean out here. And when it's ready to spawn, lay those eggs and reproduce, it swims up freshwater rivers along the coast and swims inland, lays those eggs, and then actually dies. So the seagoing rocksucker has been native out to the Atlantic Ocean forever and ever. And then at one point, it snuck into the Great Lakes. Figuring out what the seagoing rocksucker might be. So it's an invasive species in the Great Lakes, but native to the Atlantic Ocean. Give you another hint. We getting closer? So we have a couple clues, right? Out on the Atlantic Ocean. We've got that it's invasive in the Great Lakes. It looks like this guy, right? Another clue. There's a top view. It's quite long, shaped like a tube. You get closer. So this is a sea lamprey. Again, native to the Atlantic Ocean, but not native to the Great Lakes. So when it snuck into the Great Lakes, it became an invasive species and harmed our system, right? So we have these sea lamprey out in the Great Lakes, and they're doing a bunch of damage. But how did they get here, right? So like I said, they've always been native to the Atlantic Ocean. And the Atlantic Ocean is connected to the St. Lawrence Seaway, which is like a really big river that goes all the way down here to Lake Ontario. So forever and ever, they could have swum down the St. Lawrence Seaway and gotten to Lake Ontario. But there was something in the way that didn't let them get into the Great Lakes. Any guesses on what might have been the way between Lake Ontario and Lake Erie? This thing. Anybody know what it is? You can drop it in the chat if you know what it is. But this is, oh, there's some answers coming in. So it's Niagara Falls. So this huge waterfall, and to give you some size perspective, this is a bus, right? These are cars down here. This is a really, really big waterfall. And although the sea lamprey could have swam up here, Niagara Falls was in the way. And they couldn't get over Niagara Falls, and they couldn't have gotten into the Great Lakes. But being the good humans we are, we couldn't leave well enough alone, and we have to change things in order to make stuff better for ourselves, right? So having this big thing in the way keeps boats from going through here as well, right? So you have boats that could go all the way from the Atlantic Ocean through the St. Lawrence Seaway into Lake Ontario and come into the Great Lakes, but they can't get here because Niagara Falls is in the way. So what did we do? Any guesses? What did we as humans do to start fixing that problem, right? So we dug a canal, right? Because we have to make things better for us. So here's Lake Ontario, and down here's Lake Erie. And before, the river went through here, right? The Niagara River, but Niagara Falls was in the way. So although the lakes are connected, boat traffic couldn't go between them, and those sea lamprey also couldn't go between them. So what we did was we dug the Welland Canal. So men with pickaxes and shovels dug all day, every day for a few cents a day back in about 1825. And they dug this entire canal by hand. It was about 8 feet deep, 20 feet wide, so it wasn't huge. And they dug it all by hand. And what that did was across land, it connected Lake Ontario to Lake Erie, right? Very good thing for barge traffic, those boats that are carrying goods that people need, right? So maybe it was carrying food, or it was carrying iron ore, different things that we needed to build stuff for ourselves or to live. So those barges can now go through that canal. And being humans, again, we have to make it bigger and better, right? So we dug them deeper, and we dug it wider, and then we dug it deeper some more, and then we made hard sides and parts. And then we added locks. So a lock is kind of like an elevator for a boat. So the boat comes in, these doors shut on both ends. The water level raises or lowers depending on which way the boat's going. The doors open and out the boat goes. So now you can get from higher level water to lower level water, which obviously it did because there was the giant waterfall, right? So we have these locks, we're making these more and more complex, and we kept doing that for the next, 100 plus years. Now the channel looks like this. So the Welland Canal is now quite wide, very deep, and we have very, very large vessels that can go through there. Not just vessels that are hanging out in the Great Lakes, but vessels from across the ocean, right? They can come all the way across the Atlantic Ocean and now come in through the St. Lawrence Seaway, go through the Welland Canal, and get into all the Great Lakes, which is a good thing, right? That's great for commerce. But bad things can come with that. So for a long time, scientists thought that this is how the sea lamprey got into the Great Lakes, right? They always could have gotten to Lake Ontario through the St. Lawrence Seaway. But then when we put in the Welland Canal, we let them in to the rest of the Great Lakes, and that's where they came from. But now we know that probably isn't the case. There was another canal we dug. So this is the Erie Canal. Here's the Hudson River. New York City is down here, right? So the Hudson River goes through New York, and what we did was we dug a canal from the Hudson River, connecting it over here. We also made a little tiny nub that connected directly to Lake Ontario. And now scientists believe this is how sea lamprey got into the Great Lakes. But again, totally our fault because we dug the canals, right? But we also opened up the door to these invasive species. So now the sea lamprey are coming into Michigan, into our Great Lakes that are attached to Michigan, and they're spreading. So in the 1850s, they were found in Lake Ontario up here. By the 1920s, they're being found in Lake Erie. By 1931, they're in Lake Huron. By 36, they're in Lake Michigan. And by 1938, they've reached all the Great Lakes, and they are now in Lake Superior. So again, not a huge problem, right? People in the late 1800s, early 1900s, are they out in their boats, their big luxurious yachts fishing in the middle of the Great Lakes? No, that wasn't really a thing, right? So we have the Great Lakes are being invaded by a species that most normal people are never going to see, right? And it's potentially impacting fish that most people have never fished for or eaten, because at the time, it was mostly commercial fishermen. So 8 or 10 guys went out on a big boat with nets. They drop their nets. When they pull up the nets, they are full of lake trout and whitefish and Cisco, and they sell those at market. So it's not like it's individual fishermen fishing for these things. So we start having the sea lamprey showing up, and the commercial fishermen are saying, hey, there's this crazy species that's coming in. Well, why was that a problem? Well, let's see. They started impacting our native fish species. So this fish species in particular was being impacted. You've got 2 lamprey suctioned onto this one. What lamprey do is they have a big suction cup disc mouth with hook-like teeth. And what they do is they suck onto the side of the fish, they kind of embed those little hooks, and then this crazy rasping tongue, kind of like a shovel, and it digs a little hole, and they suck the body fluids of those sea lamprey. Or the sea lamprey suck the body fluids of that fish. So these sea lamprey attach to these fish, they hook on, they rasp a little hole, and they suck the body fluids out of these fish. Now, is that killing the fish? I don't know. Have your parents ever donated blood? Right? It doesn't hurt them. They can donate blood every couple months, and it's totally fine. So it may not be that the fluids are getting sucked out of this fish that kills it, but when those lamprey let go, what do they leave? You know, pretty nasty wounds. Now, when you get a wound, right, you wash it really good with antibacterial soap, you put some Neosporin on it, you put a nice Band-Aid on it, you keep it clean and dry so it doesn't get infected. Now, do fish have that option? Not so much. So when the lamprey let go of these fish species, they leave that big open wound, it potentially gets infected, and usually the infection is what kills the fish. So let's look at this species of fish and see if we know what it is. So here's that fish species. I can't even back up far enough to get him in the picture. It's a pretty big fish, right? So it's kind of got a greenish brown tone to it, some speckles, nice big mouth, so you know it's probably a predator. And it's got this funny little fin in the back here called an adipose fin, which teaches us that this is probably in the salmon and trout family. Now, salmon were not in our lakes at this time, so it's probably a trout, right? And this one lived out in the Great Lakes and hung out. So being fish biologists, we're not terribly creative. So what do you think we named a trout species that hangs out in the Great Lakes, right? This is a lake trout. So this was the big predator species out in the Great Lakes in abundant numbers. And we had them out in the Great Lakes, and they were out doing their thing. They're the top predator. They're eating smaller fish. Those smaller fish are eating plankton, very happy fish. And then along comes the sea lamprey. So those sea lamprey now are latching on to our lake trout. They're sucking those body fluids. When they let go, they can potentially cause big wounds that get infected and killing off the lake trout. And they definitely did. So as this was happening, we've got a big problem, right? We've got more and more lake trout being picked off by sea lamprey, and the population of our native lake trout goes down dramatically. So we've got a huge decline in the lake trout. So you can see this is the 3 different lakes, the different types of symbols. And you know, the populations go up and down over the years, but once those lamprey were in all the Great Lakes and becoming more and more abundant, look what happens to the trout numbers. They go down and down and down and down, almost to 0. So now we've got a huge problem. Those commercial fishermen and the communities they lived in were dependent on these fish and catching these fish to sell. So now there's none of these fish. We need to come up with some sort of solution, right? So these lake trout are being impacted, but not just lake trout, other lake fish species were as well. So we need to come up with something to do. The first thing would be to understand the lamprey life cycle. So we know when they're adults, they are parasitic, and that means they hook onto the side of the fish and they suck those body fluids, and that's what they live off of. But what do they do for the rest of their life? We know when they're adults, they're hanging out in the ocean, the Atlantic Ocean, or out in our Great Lakes where they're invasive. But what do they do when they're younger? Well, when those adults decide they want to have babies, they unlatch from the fish and they swim up a river. And then they lay their eggs in that river along the stream bed. So the sediment, the mud on the bottom of the river, they lay their eggs there. And then the adults actually die. Well, what happens to the babies? Well, those eggs will hatch. The young sea lamprey burrow down into the sediment, that mud at the bottom of the river, and they can live there for years and years, like up to 10 years. And what they do is they stick their tiny little heads out. And at this point, they are filter feeders. So their mouths are sticking out and they're catching plankton that's floating in the river. They're not actively hunting or seeking out food. They just are filter feeding the things that come down the river into their mouths, right? So one day they decide they're going to be teenagers and they're going to dig out of the sediment and they're going to go out to the big lake. So they come out of the sediment, and as they are transitioning out to the Great Lakes, their mouth turns into that parasitic mouth with the Velcro suction cup and that rasping tongue. And by the time they get out to the lakes, they're now adults, and that's when they start feeding off of body fluids of those big fish. So again, when they're little, they look like green beans and they're down in the mud. Those eggs are on the bottom of those rivers. So if I was a scientist and I was going to try to take care of these things, am I going to go out in the Great Lakes and chase them when they're hooked on big fish, where lake trout can be a couple hundred feet over the water? Or would it be easier to catch them when they're not moving and hanging out in rivers? So that's what scientists started to do. They focused on the rivers very specifically. The first step was to maybe catch some of those adults, or maybe not let the adults go up the river. So you can use a weir for that. So a weir is like a small dam, kind of like a fence across the river. The water can still flow over, but these lamprey can't jump over this weir or these small dams. So we're preventing the adults from getting up the river to spawn. And another thing we could do, well, we could add like traps on the side of these weirs. So the lamprey get up here, we can kind of coax them into these traps using pheromones, like hormone smells, and we can catch the adults and get them out of the river. Well, that's one way, right? We're keeping those adults from spawning, and we're not letting them have babies in the river. That stops the ones that might have laid eggs up here. What about the ones that laid eggs here? Did that stop them? Nope. Now we have to come up with another part of our solution. So what do? Chemists worked really, really hard for a long time to come up with a chemical that would treat especially the larvae and the eggs of these sea lamprey. And where do they live? Well, on the bottom of the river. So we're going to target them very specifically in rivers. Well, what time of year are the rivers the lowest and moving the slowest? Kind of like the end of summer, right? So we're going to try to aim for like midsummer, end of summer to treat these rivers. And the scientists go out here and you have to do a lot of math, right? You got to know how deep the river is, how wide it is, how much water is moving through it, and how fast, to calculate how much water volume is going through there. And then they kind of use like a drip hose system to treat the river with TFM. It's got a really long chemical name, but TFM is the chemical that was developed to very specifically go after sea lamprey. It doesn't really hurt other fish species. By doing it late in the summer, we avoid interactions with like frog eggs and salamander eggs, which would be vulnerable to it. But we're trying to keep it separate from things we could hurt. We're treating it when the water is low and slow, and trying to treat these young sea lamprey. And you can see, so the blue lines here on the chart are the lake trout population, right? So they were always doing pretty good. It goes up and down, but that's normal based on their food. But then lamprey come in, and you have tons of lamprey coming in, and the lake trout just bottom out. We'll then introduce TFM. And when we introduce this chemical, look how low the sea lamprey population gets. It bottoms right out, and we've kept it there over the years, right? But this comes at a cost. So those sea lamprey treatments cost about $20 million a year. The U.S. Fish and Wildlife Service travels all over the state. They select certain rivers each year, and they treat these river systems with TFM, but it costs $20 million a year. So with that $20 million, we're knocking that sea lamprey population down. But what if I told you as a voter, so someday you guys are going to vote, right? As a voter, I'm like, I need $20 million a year to treat this invasive fish that you've never seen, that hurts other fish that you've probably never seen or caught, and I need that $20 million. If you didn't know better, you would say, well, that's a bad deal. Why would we spend $20 million on that? But this fishery is worth $7 billion. So the fishery in Michigan is $7 billion worth of income. And it's not just directly with fishing, right? So if you're going to go fishing out in the Great Lakes, you are going to get up in the morning and you're going to hook your boat to your fancy truck, and you had to buy both of those. And you're going to load your fishing rods and all your gear. You had to buy all of those. And then a cooler and some ice. And you're going to add all those bits and pieces. And you're going to travel out to a Great Lake. Well, you have to buy gas for the car and the boat, right? And on the way, you get hungry. So you stop and buy some snacks. And then you go out fishing all day long and you catch your fish. And you come back and you're tired, right? So you have to go to a hotel room. And you gotta, eat dinner. So you go to a restaurant. All that money you've spent is part of that fishery, right? You wouldn't have done any of that if you weren't going to go fishing. Plus the rods, the boat fuel, all of those things you bought have excise taxes on them. So the federal government takes some tax money that they give back to the states to help protect the resource. So all of that money folds in. So when I say we're going to spend $20 million to protect a $7 billion fishery, that sounds like a really good deal, right? So that's a good thing to know. Now, we've got these sea lamprey that we're starting to get under control. The lake trout populations are starting to rebound a little bit, but there's another problem. And of course, it's because of humans and what we've done. And that comes in the form of another invasive species. So this little bait fish here. So a bait fish is something, a smaller fish that is consumed by bigger fish. So this particular bait fish is called an alewife. And an alewife is another invasive species to the Great Lakes. It probably snuck in through those channels, right? But the alewives were in big numbers out in the Great Lakes. They eat plankton, and they were reproducing very well because the plankton populations were doing well. And the lake trout were eating them and keeping them in check. Well, what happened to our lake trout? So the lake trout populations go down. Alewife populations boom because now there's a lack of predators. And then what happens if they start getting overpopulated? There's not quite enough plankton for them to eat. Well, they start dying. And what happens when lots and lots of fish die? Well, they float around and they wash up on beaches. So now we've got piles of alewives on beaches. I mean, piles and piles and piles of alewives. And, as a beach goer or a camper, that's not something you want to smell, right? That doesn't smell very good. But what if you're one of those really fancy people that owns a very fancy beach house out on Lake Michigan, and you have dead alewives washing up on shore that they have to use bulldozers to move? Well, you're not going to be very happy. So these fish are coming in and not having a predator, and they're reproducing in great numbers, and they're dying off. Another problem to fix, right? So how do we fix all of this? So we're starting to get through the sea lamprey problem, but now we have this alewife problem where they're all washing up dead because we don't have a predator for alewives. So the fisheries chief at the DNR at the time had to come up with something, what they said was something spectacular, right? So Dr. Howard Tanner was tasked with coming up with something spectacular, not only to provide a fishing opportunity in Michigan, but also to maybe help with this alewife problem, right? So what was his solution? Well, he had just moved back from out west in the United States. And out west, they have other species of fish that might eat these alewives. That is where salmon comes into the equation. So out in the Pacific Ocean, we have salmon species. These are some of the salmon species out here, these 5 species, and they live out here in the Pacific Ocean. As they become mature and they want to reproduce, they swim up those freshwater rivers, and some of these fish go all the way up here to Montana, Idaho, into Oregon and Washington. They swim up those rivers, they lay eggs, they spawn, and then they die. So these Pacific salmon species, when they're out in the ocean, eat a lot of those bait fish. They eat squid and other things, but potentially they could be a problem or a solution to this alewife problem. And they would kind of be fun to fish for. So they brought these species to Michigan. Now, part of the plan was we kind of had to change how these fish acted. So in their native habitat, these Pacific salmon are anadromous. And what that means is as adults, they live out here in salt water. And when they're ready to spawn, they swim up those freshwater rivers. So they're going from saltwater to freshwater. The babies live in freshwater. As they mature, they head out to saltwater. So these fish are kind of changing physiologically in how they work, because most fish can't do that. They can't switch from freshwater to saltwater, where these salmon could. But now we're going to bring them to the Great Lakes, and they're going to have big freshwater, right? The big Great Lakes, and they're going to swim up freshwater rivers. So now we are going to make them be petadromous, right? They're going to go from big freshwater up to rivers to spawn. So we're changing kind of the physiology and how these fish would naturally work. but we're bringing them to Michigan. So what we did was we introduced them into 3 places. They brought back eyed eggs from out west, raise them up in hatcheries, and then drop them in. And then they wait. Because how long does it take for these fish to mature, right? We're putting in fish that are this big, you know? They're not very big yet, and they're not able to be caught on a fishing pole. Well, we wait for a couple years, and then we start to see something in the fall. As these fish are now mature and quite big, they're coming back to the places where they were introduced. It's called their native river, and they're coming back in big numbers. So now all of a sudden there's this huge silver fish coming in where guys and waiters can wait out, and you know, they can take their families on a boat and go out and catch these fish, or they can go and hang out in the rivers when they're coming up to spawn. And it created a huge new fishing opportunity. And of course, they're quite yummy. At the time, you couldn't find a hotel room for big chunks of the state, and you couldn't buy gas. Like, they were running out of everything because so many people were flocking to the area to go fishing. So the fish that they introduced at this time was the coho salmon. So here's our coho salmon. It's a little different color than our lake trout, right? So the lake trout was very brown and green with speckles. These guys have kind of a silvery with a bluish coloring. They have some speckles along the back, but just a few. Again, that nice big predator mouth with some little teeth-like bits. They have this special fin in the back called the adipose fin, so we know they're in the salmon or trout family, right? So these are our coho salmon that were introduced. And these worked so well, you know, they thought, why not try another one? So this is where our salmon in the classroom species comes in. Chinook salmon were introduced a few years later. So now we've got another species coming into Michigan that could potentially be a new sport fishing opportunity, but also help with that alewife population. So these Chinook come in and provided all of that, right? So now, not only could you buy fish in the store from those commercial fishermen, but you yourself could go out in your boat, or you could go out with a charter boat and go out into the Great Lakes and fish for salmon and do quite well, as you can see, right? You can also fish in the rivers during spawning season. So as those fish are swimming up the river to go lay their eggs, you can catch them in the river, and it's this whole new fishing industry. And thankfully, it also helped with the alewives, right? So now we have this new predator fish. Lake trout populations are coming back up because we're treating the sea lamprey, but we also have the salmon taking some of the pressure from the sea lamprey, but also helping eat those alewives. So let's look at our Chinook. Much larger. Again, I can't even fit them on the screen. Much larger than the coho, larger than those lake trout. These guys have the speckles along their back. Their whole dorsal fin has speckles, as does their whole tail fin, their caudal fin. So these are our Chinook, and we also have that adipose fin. So we know it's a salmon or a trout. So these Chinook are now a top predator in our lakes. And what we need to do is worry about keeping the balance. So as fishery management, you know, and scientists in our state, that's what we have to do a lot of. So we've got these fish species coming in, but we need to keep maintaining their populations, and we want them where we need them, right, to eat those alewives and to do what we need them to do. And that's where fisheries management comes in. And fisheries management takes a lot of pieces. So the first piece is our research vessels. So we have boats on each of the Great Lakes that do research. Now, this is the retired boat from Lake Huron, but I had to include this picture because it's named the Chinook. And you can actually see this boat on display now at the Besser Museum in Alpena. But this was the research vessel for Lake Huron, doing a lot of this research as we're trying to understand the salmon populations and the bait fish populations and the plankton populations, right? And we have those vessels on each of the lakes doing this kind of research. We also have to maintain the eggs and rearing program. So rearing is raising those fish. And we do that by utilizing weirs. So our salmon population swim up the rivers to spawn. We put these weirs, which is kind of like a fence across the river, and it's temporary in this case, that kind of stops the migration of those salmon. And it funnels them up into ponds that we can then pull those fish, euthanize them nicely, right? Because they're gonna die anyway. We can collect the eggs and milt from the males. And then we fertilize those eggs and take them back to hatcheries and raise them and then stock them into the Great Lakes. So through these stocking programs and the use of our hatcheries around the state, we are now maintaining those numbers. So we have to understand the bait fish populations, we have to understand the plankton populations, And those have now been affected by zebra mussels and kawaga mussels, more invasive species. And I call it riding the wave, right? Like we need to understand all of these different pieces in order to get a balanced equation. And that equation is going to change every single year. Our fisheries biologists spend their winters crunching numbers and trying to figure out what the new patterns are going to be. And we need to do a lot of this to maintain the system. So let's watch a quick video here that kind of explains the salmon program in Michigan and also gives us kind of a glimpse at the life of a Chinook. Since the 1960s, Chinook salmon have become an important piece of the puzzle that is the $7 billion per year Great Lakes fishery. But the story doesn't start here. Chinook salmon were introduced to the Great Lakes in the 1960s thanks to eggs from salmon in their home range of the Pacific Northwest. To supplement wild populations, the Michigan Department of Natural Resources maintains a salmon rearing program in our state fish hatcheries. In their native habitat, they are anadromous, migrating from rivers to the Pacific Ocean and back. In Michigan, Chinook salmon are petadromous, meaning they travel from rivers to a Great Lake and then return to their natal rivers as adults, where they then spawn and die. This marks the end of their life cycle. The DNR maintains weirs around the state, which are used to block the upstream migration of fish. The Little Manistee River Weir, located on the river that bears its name, is the main egg take location for Chinook salmon in the state of Michigan. The adult fish are diverted up a fish ladder and into holding ponds where they mature prior to spawning. Staff gather each October to spawn the Chinook. Fish are mechanically crowded into a building and humanely euthanized. Once euthanized, they are checked for ripeness, sorted by sex, and placed in a disinfectant bath of iodine to remove any external pathogens. Fisheries staff make every effort to only spawn wild fish. Those with missing adipose fins are hatchery-reared fish and will not be spawned. Females are then stripped of their eggs, while males are stripped of their milt, or sperm. The 4,000 to 5,000 eggs from one female are fertilized with milt from one male. The fish go through a disease inspection and are then placed in bins for human consumption and pet food. All parts of the fish are harvested and used. No portion is wasted. After the eggs have been fertilized, they are placed in a water bath containing thiamine for a period of 1 hour. Chinook salmon feed almost exclusively on alewife, which lowers the thiamine level in the salmon. Egg batches are then mixed into 5-gallon buckets where fresh, clean water provides oxygen. Eggs are disinfected one more time with an iodine solution and then transported back to a state fish hatchery. At the hatchery, green eggs are placed in incubation trays. Water is constantly circulated through every tray, each of which houses 7,500 eggs. Eggs hatch in approximately 45 days and begin living off their yolk sac. At this stage, they are called sac fry or alevin. Upon absorbing their yolk sac during their first month, called buttoning up, the Chinook are transferred to larger tanks as swim-up fry. In these tanks, they are provided all their needs of life, including food, water, and shelter. As the young Chinook salmon grow over the winter, their markings become more complex, and they become adept at feeding. At this stage, they are called parr. As the parr get bigger, they start to lose their camouflage markings and take on a more silvery appearance, which is called smolting. This is the stage where state fish hatcheries begin stocking the fish into rivers around Michigan. Fish are weighed and pumped into stocking trucks, driven to their assigned site, and then released into the water. Some are transferred into holding pens to be fed a little longer, and then they are released. These fish, now with a solid silvery appearance, are called smolts. They will imprint on their natal stream and forage for food. As they grow larger, they will make their way downstream to one of the Great Lakes, where they will live for the next couple years. While in the lake, they consume alewives and other fish swimming in the middle of the water column. They can gain up to 30 pounds in those few years while reaching maturity. Once mature, they will make their way back to their natal stream in the late summer and early fall. This is a great time for anglers to focus on catching a Chinook salmon, either from a boat in the lake or in the stream as they migrate to spawning locations. Once in their natal stream, Chinook salmon migrate until they find the perfect spawning habitat. Females then make a red
or a nest, in the gravel. After spawning, they will die and become part of the river's nutrient cycle, with their young starting the whole process over again. For more information, visit michigan.gov/SIC.
So hopefully that kind of gives you a better glimpse of the life of a Chinook salmon here in Michigan. And again, they are going to migrate, so we have to keep track of them in all different lakes, and we need to keep track of their populations, and there's a few tricks on how we do that. So before those fish are loaded in those trucks, we can actually use a U.S. Fish and Wildlife Service trailer and pump the fish through this trailer, and it puts a little tiny tag in their snout, right, their nose, and it also clips off that adipose fin, which doesn't hurt them. But then we go and we stock them, and someday they're going to come back as a big salmon that someone's going to catch. Well, if that fin is clipped, that tells the fishermen that those were raised in a hatchery, and they could turn that head in, and we can read the code on that little tiny tag in their snout and figure out where the parents were from. And, we spawned them at the Little Manistee River Weir, that those eggs went back to the Wolf Lake State Fish Hatchery down near Kalamazoo. And we could even tell you like who probably fed them, right? But then it also tells us where they were released into a river or the Great Lakes and when, right? So we know how old that fish is, where it came from, where it probably swam to, because now we know where it was caught. And it tells us a lot of great information. So fisheries managers take care of these fish and the populations and, keep track of all that data to keep those populations healthy for you, so that you and your family can go out salmon fishing, or just so that we can raise them in our classrooms with salmon in the classroom like this. So that takes care of the History of Salmon program for today. But if you guys have questions, go ahead and drop them in the Q&A. And I have a couple minutes where I can answer some of those. Looks like we already have one question in there. Let's look. How do the salmon survive big waves, if there are any? Now, there are definitely big waves out on the Great Lakes, right? So there are even rogue waves, right? If you've ever heard of the Edmund Fitzgerald, a big vessel that was sunk, that one was probably by a rogue wave, right? So there are big storms in the Great Lakes. These are really big bodies of water. So there are definitely waves out there, right? But these fish can kind of handle it, right? What do they do if there's really choppy waves at the top? They just go deeper, right? Chinook salmon pretty much swim in the middle of the water column, so not at the top and not at the bottom, and swim along and eat whatever in front of their face. And thankfully, that's alewives usually, right? So they actually, swim through and, just eat those alewives that are in the middle of the water column. So they stay pretty stable. Someone asked, what predators do Chinook salmon have? So when they're young, they probably have lots of predators, right? So right now they're sac fries. You see the tiny little guys laying on the bottom. In the river, they would be kind of down in the gravel just hiding, because they are prime candidates for a predator picking them off. So crayfish, other fish species, birds that hang out along the shore, they're all going to be eaten by those things. As they get bigger, they're going to go up into the water column and start learning to feed and start swimming in the river, and they've got to fight the current now, but even bigger predators could eat them. So bigger fish can eat them. Crayfish can still eat them. Birds that are fishing now are going to eat them. So there's definitely more predators when they're little. As they get bigger and bigger, those predators drop off. So when they're young guys, they could be eaten by, say lake trout or pike or muskie, but they are going to outgrow them really quickly, right? Because it only takes them a couple years to get full size and mature. So as they get older, they're going to have less and less predators, and their main predator is going to be us as humans, right? Let's see. Oh, how many salmon in the world right now? Like, that's probably a lot, right? It's really hard to keep track of the full world's population of salmon. But if you want to see what kind of salmon are being stocked in Michigan and how many, we actually have a whole page about stocking. So you can look at the Michigan ER page for stocking and understand how many fish we're putting in the water and where. It's kind of cool. Are there other states who have fish problems? Of course, right? Because as humans, we make a lot of problems as we're trying to fix other problems. So there are definitely other states that have fish problems. And again, these salmon are from the Pacific Ocean. They're from Washington and Oregon and Idaho and Montana. They're from states far away. They live all the way up through Canada and in Alaska. The Chinook salmon in Alaska and out west is called the king salmon because they're the biggest one, right? So there are lots of these salmon out there, and there's lots of salmon everywhere, and they all have different issues. Out west, when these salmon try to go up the rivers. A lot of those rivers have been dammed, mostly for hydroelectric power, right? We're trying to generate power with these huge dams, but it prevents the fish from migrating. So they've put in fish ladders and other fish passage systems to try to get them up, but now you're trying to help fish populations recover, which is always an uphill battle, right? You have to get more and more fish as opposed to keeping them happy in the first place. And then someone asked how big a salmon can get. So in Michigan, they don't get quite as big as they do out in the Pacific Ocean, but our Chinook salmon can get quite large. They can get over 30 pounds. And this one is, quite big, right? 3-4 feet long. They can get quite large. Out in the Pacific Ocean and up in Alaska, they can get to be almost as tall as a person and weigh 100 pounds. So they get much larger out there. But here in Michigan, 30 pounds is pretty darn good salmon. Okay, I think that's all the time we have for questions, but I want to thank you guys so much for being here. I wanted to share a few other resources we have available to you. For teachers, you can visit michigan.gov/nature at school, and you can find a whole host of topics that you can book as live virtual programs, like a virtual field trip right in your classroom or right through your computer. We have about 11 topics right now with more coming soon. Or families or homeschool groups can go to Nature at School and book a webinar format. So we offer our topics as webinars where as many people as possible can join. Not quite as interactive because we don't see our students, but those webinars are super educational and very much like this History of Salmon presentation was. Another resource we have available is called Nature at Home. Again, michigan.gov/nature at home. And this is filled with zillions of resources. So class activities, home activities, where you can get out in nature and do some cool stuff. Different video playlists to help you connect with all sorts of pieces of nature. So a great way to get your family outside and enjoying nature throughout all of our seasons here in Michigan. Our other resource is our My Nature DNR Facebook page. This is kind of the warm and fuzzy side of the DNR. So each day of the week, we share cool, fun content that has wildlife in it. It has different opportunities, places to visit, all sorts of stuff. So definitely find My Nature DNR on Facebook and like that. Again, thank you so much for being here, and I hope that you take advantage of some of our other webinar opportunities.